Hello, this is Aaron for Chef. In this video, I'm going to show you how to use the Atom Sop Solver. The Atom Sop Solver is a new solver added to Atoms 5.4 that can be used to simulate the Atoms crowd at SOP level. So, for example, you can use the Houdini core license, that the Houdini FX license to simulate Atoms agents. So, to create an Atoms Sop Solver, you just go through the Atoms menu and create agent group here with the Sop Solver. Now I have my agent group. So we see the agent group is exactly the same nodes, but then we have the new Atom Sop Solver node. So let me create some agents. Okay, let me add some animation. Okay, so let's go back and dive in to the atom inside the Atom Sop Solver. So the Atom Sop Solver is split in different nodes. The red nodes are the nodes that call the atoms events, and they are basically those nodes called, for example, the init simulation, then the init frame of each behavior module that you have on the agent group. Then we have the compute pose that compute and evaluate the graph of each agent. And then we have the end frame that call the end frame methods for all the behavior components. And then we have the end Sop Solver. You will see here those green subnetwork. Inside this green subnetwork, you can modify the agent data and access the agent data on the points attribute of the input geometry. Because basically every of those nodes here read the simulation from Atoms, read each agents, and then write as output a points cloud, and on each point represent an agent with some metadata exposed on the as a points attribute. So every node do this. So it read the input and check all the points attribute, also convert those points attribute to agent metadata. Then it do its calculation, and then read the data from each agent, so read the metadata from each agent, and set back the new metadata value on the points attributes. In this way, you can modify any agent metadata you want, just setting points attributes on these geometries. For example, I can modify the direction of my agent just using, for example, an attribute create, or we can even use an wrangler. Let's set this one to vector direction, and let me set to 1, 1. To see the simulation updated, you need to go outside the Sop Solver. In this way, you will see the final, the real, the final basically simulation for this frame. And then you just press play, and you have the simulation. Since this one is a sub node, if you press and stop, for example, if you go back, you will see you don't have a cache like the DOP network. So every time you stop, you can't scrap. You need to basically just go back and resimulate again. So here basically you can manipulate the points attribute, so you can manipulate the metadata. You can even generate or expose new metadata. For example, I can add another attribute create and call this, I don't know, foo. Oops. Foo. Let's set, I don't know, the value 5. And now these points attributes will be converted by the compute post to to an agent metadata. So if I go back to my agent group node, go to the draw, I can check my new metadata, and you will see. So this way is really easy to manipulate metadata and you setting data directly on the points attributes. Otherwise, with the DOP network, you usually need to use a VEX module or a Python beaver module to modify the metadata of the agent. In this way, it's really easy to trigger the simulation. We have also another node that's useful to manipulate the simulation. So we have, for example, here on the preframe, I can add the where is the Atoms create module attribute. This one basically generates a points attribute that can be used to drive the attribute of a module instead to drive a metadata. Because basically you can in Atoms you can drive the value of each attribute that you can override per agent using a specific metadata name that is composed by the name of the behavior module and the name of the attribute. And this node basically here generates the right name for you. For example, I have the state machine, and imagine you want, in this case, the state, but with the state you can also change the metadata directly. And if I check the data now, you will see this new node. So now we have our attribute that we can change to change the state of the agent. So let's add an attribute create node, and now we can change our state machine. Add states, encoding the name, and this one is going to be an integer, and let's set 2. Now we see we set the right value, go outside the solver, now we have the new state. Obviously you can change the state here, also changing the state metadata directly instead to change and set the behavior attribute. But in case you want to set a specific behavior attribute, now you know how to do it and control that using the points attribute on the geometry here. Okay, now let's have a look to the last node that could be useful with the Sop Solver. That is the Atoms copy metadata. This node extracts an agent metadata and create a points attribute with the same name and value. So for example, if I want to extract the state metadata, now I have the state here. So if I want to change this one, let me remove the state machine state, because now we are going to change the metadata instead. Here, and let's go on the state machine and set state only agent creation only, and now we can drive the state using the state metadata. So here I go here and then set my states and set to integer, and now walk. I go outside and I have the work state. So that's it for the Sop Solver. Thank you for watching.